three libraries. More, yeah, we are going to cover three libraries. The first library which we will cover, it will be the math library, and under the math library, we learn how to the different ways of how to import the math library. Then we'll tackle some examples under the math library, such as square root, exponential, log, power. All those functions are within the math library. Then the second library which we will cover, it is the random library. Under the random library, we'll have functions such as random. We'll have functions such as randrange and seed. Then we'll cover the time library. And under the time library, we'll learn how to process time, which is a function. And also we'll cover the sleep function. Let me start now. In this chapter 6, as I've told you earlier, it will cover on how to use function. And the first function which we'll cover, as I've told you, it is the math library. Now, in this math library, it has got all the mathematical function, be it square root, sine, cosine, absolute, exponential, log to base 10, and what have you. It has all, it has got all mathematical function. So the first thing we are going to learn is how to import this math library, and how to maneuver with the function within it. The first example, we are going to tackle the square root function and how to handle this square root function in Python programming. So the first way to do it, to tackle a square root, you will say now, this is how you will import it. You will say from math, math is the library. So it is from this math library that we are going to get the square root function. So you'll say from math, import square root. And square root in Python programming, it is written as sqrt. So from this math library, you import square root. And after you have imported square root, you will be now in a position to compute a square root of any number. For instance, here, you see I want to get the square root of 16. So you will write sqrt, then in bracket 16. So when you run this cell, you realize it will give you the square root of 16 is 4. The same way, when you want to get the square root of 49, and when you run, you see the output is 7. So the first way of how to import a square root function, as you have seen in that example, you say from math import sqrt. So it means when you will import in such a way, it will only come with a square root function. The second way to do the same, instead of writing from math import sqrt, you will write import math. You will write import math. And after you have written import math, that means now you have imported this library known as math. After you have imported this library known as math, it comes with all the functions within it. Now, for you to compute square root here, it will be slightly different from the first case. You saw when we said from math import sqrt, when we wanted to compute square root, we just said sqrt in bracket 16. But in this case, when you will say import math, when you want now to compute square root, you will now say math.sqrt, then in bracket 16. You will now say math.sqrt, then in bracket 16. So when you will run, it will give you the square root is 4. It will give you the square root, it's 4. What about when you want to do the sign, when you want to get the sign? So in this case, you'll say import math. Then, because you have just said import math, you have not specified from that math what function will it get out, will it derive out of this math library. So when you come here, you will say math.sin. So it means you are dot sign. It means you are going to get the sign of 49. And when you will compute, it will give you, it is negative 0.95. That is when you use the second way. But when you use the first way, you will say from math import sign. From math import sign. So when you say this from math import sign, you see now, uh, when you want to get the sign of this angle 49, it will be slightly different compared to when you said import math. When you just say import math and you want to get the sign, you have to say math.sign. But when you say from math import sign, you'll just say sign 49. And when you run, it will be able to compute for you the sign of that angle. The other way now is now this is now the third way. The third way now is where now you do an importation, which will enable the math function to come up, where the math library to come up with each and every function. And this is the way you do it. You just say from math import star. So when you say from math import star, this math library will come up with each and every function within the math library. So in this case, you don't need to specify as we have been doing in our earlier cases. So in our earlier cases, you remember, for example, if I want to get the square root, I will either say import math or I say from math import sqrt. But in this case, when you say from math import star, this star in under functions in Python programming, it means now it has come out with each and every function within the math library. So when I say that, I will just come here and compute my square root. If I want square root, it will give me 4. If I want the sign, I just say sine 49. It will give me. If I want the cos of 49, it will give me. And also you'll realize, for example, you see here I've imported everything from math import star. So here it will just give me the square root of 16. It will give me the square root of 49. It will give me also the sine of 49. It will give me the cos of 49. It will also give me the cos of 16 in that order, in that order. And also, if I can come up with another example, you see, I've not said from math import. Uh, you see, in this case here, I said from math import cos. But in this cell 8, I just said from math import star. I didn't specify the cos, but when I computed the cos, it was able to give me the cos value of that angle. And also, if I can give you another example, for example, I want to get an absolute. So I'll just I don't need to import. I say from math import maybe fabs, because an absolute value in Python programming is represented by fabs. I'll just come here and say fabs bracket. I want to get an absolute of a value like 45. So when I run, it will display for me the absolute value. The same way, for example, I want to get the radian. For example, I want to get the radian of, for example, 70. When I run, uh, is it radian or radians? Let me see, radians. When I run, you see it gives me the radians. So when you decide to go by importing everything, each and every function within the math library, you just say from math import star. It will come out with each and everything within the math library. It will come with each and every function within the math library. So there are three ways of importing. The first one, you just say from math import, you specify the function which you want to import. Then the second way, you say import math. You import math, but now in this case, for example, if you will want to find the square root, you will say math.sqrt. Then the third way, you say from math import star. This means it will come up with each and every function within the math library. Further examples. For example, if you want to develop a program which can be able to compute a square root, you want to develop a program which can be able to compute a square root. The first thing you'll say from math import star. So I've used one of the ways. You say from math import star. That means it will come up with each and every function within the math library. Then now I want now to start making my program. I say new, because any number that I will enter, it will be numerical. So I've just decided to write it in short form. I say num is equals to eval. So why am I using eval? I want this program to accept either a float or an int. So after that, I want now to get the root. So I'll say root, and you know what stands for what computes a square root under function. It is sqrt. So I'll say sqrt, and you want to get the square root of which value? You want to get the square root of num. So I'll say root is equals to sqrt of num. Then I will expect the program to print the results. So in this way, when I run, this program will ask me for a numerical value. When I will enter a numerical value such as 81, and I press enter, it will compute for me the square root, and it will tell me the square root of 81 is 9. That is the first example. The second example, you saw in the first example, I just imported it by saying from math import star. I didn't specify for it to import square root, sqrt. Why? Because when you import in such a way by using star, all the function in the math library is imported. Now, in this second example, I want just to use a specific way of importing. I want to import specifically square root. So I'll say from math import sqrt. Then I want to get maybe a square root of a value such as 16. So I have my variable here x. I'm assigning it to a value 16. After that, I will expect now uh, the second thing now, I want to get the square root of 16.0. So and after I get that square root, I want it to be displayed on the screen. That is why you see I've written print sqrt 16. Then for the third one, I want now to get the square root of x, the square root of x. And since this x here, I had assigned it the value 16, this means I want to get the square root of 16. For the fourth value, I want to get the square root of an expression. And this expression is 2x minus 5. So 2x minus 5. And you need to recall the value of this x is 16. So it means 16 multiplied by 2 is 32, minus 5, 27. So it means I want to get the square root of 27. Then for the last value, also it is an expression, y is equals to square root of x. So I want to get now this square root of x, and this x was my variable, which I assigned it to 16. So when I run this code, it will give me 4. The first answer will be 4. And this 4, it is the response for print SQRT 16.0. Then the second answer also will be 4, and this 4, it stands for print SQRT of x. And I told you this x is a variable which has been assigned 16. So this means it is getting the square root of the of 16, which is 4. For the third value, I'm computing the square root of an expression, and my expression is 2x minus 5. And the value of this x was 16. So it means it is 32 minus 5, which is 27. And practically in your calculator, when you will compute the square root of 27, it has to give you 5.196. Then for the last value, it is also an expression. You see y is equals to the square root of x, and our x is 16. So it means you are computing the square root of 16, which is 4. Further example, I want to get also the square root of an expression. And when you want to get a square root of an expression, uh, all the variables must be defined. For example, this expression has got 2 multiplied by the square root of x plus 16 minus 4. So before you compute this square root of an expression, you have to define you have to define the variables within that expression. And the variable within this expression that you are having is x. So how will you define? You have started by assigning the variable x to a value 16. So it means you have defined. So this expression, if now you substitute x by 16, it will read as follows. It will read as 2 multiplied by the square root of 16 plus 16 minus 4. So that is it. So when you run this cell, it will give you the square root of that expression. The same thing now in this other cell, you are running the square root twice. Python will compute when you want to run the square root double. For example, in this case, you are saying the square root of 256. So at first, when you get the square root of 256 is 16. But you see now you have to compute this square root twice because the square root appears here twice. So manually, if you compute the square root of 256, at first you will get 16. And if you compute the square root of 16, you will get 4. So that is when you run this cell, you will realize it will give you 4. Now, the other thing which you need to know is that square root function can only compute an integer or a float value. Square root function can only compute an integer or a float value. When you feed a string, when you want to compute, you use the square root function and you write your value to be a string, it will give you an error. And that type of an error is a type error because when computing a square root only requires a real number. But when you try to enter a string, it will give you a type error. For example, in this case, you see I want to compute the square root of 45. And this 45, I've written it in string form. And I've told you time and again, how will you know that a number is in string form? You will know a number is in string form when that number is written in between the quotation mark. So this 45 is a string, but before that number 45, you see before this bracket, I've written int. This means now, although I've written this 45 in a string form, but I've specified that it is an int. So when I will compute, it will give me the results. But now, it will give me the results to be 6.7. But now look at this case. I've just written print sqrt 45. This 45 is in between the quotation mark, but before that 45, I didn't specify if it is an int or a float. Therefore, Python will take it as a string. And when it will take it as a string, it will give you a type error. Because that 45 is inside the quotation mark, it is neither a float or an int. So it will throw a type error, telling you that Python cannot compute a square root of a string value. Now, as I have told you earlier, that for square root, Python can only compute a square root of a string or a float. Now, in this case, I've written print sqrt and then eval 45. This 45, I've written it in string form. Why have I written it in string form? Because it has quotation marks. But before it, I've specified that it is an eval. So in our earlier topics, I told you an eval function, it is a function, when you use eval function, it will allow a programmer to enter either a string, a float, or an int. So when I've used this eval function here, this means the program has been given a freedom either to choose a float or an int. Therefore, in this program, it will run and compute the square root. Why will it run and compute the square root? Because I've put there eval. So it will assume that 45 is either an int or a float. So that's why here you see it is running. And the same way here, you see I put this 45, which is under the quotation mark, but before it, I specified it to be a float, and it ran. So you have to note that when computing a square root, it can only be done to a float or an int, but a square root cannot be done to a string. And further example here, you can see this 16 is inside the quotation mark. So when it is inside the quotation mark, it means it is a string. And when you try to run that cell, it throws an error because square root can't be computed for string values. The other thing which I want you to get it clear is that when you are computing a square root, you must only have one argument. You must only have one argument because the square root function cannot handle more than one argument. When you try to enter more than one argument, it will throw an error. Example, you see here, I want to compute the square root of 5 and 7. So it goes against the rules of computing the square root using a square root function. Because when you are computing a square root function, you must only have one argument. But in this case, I have 5 and 7. Those are two arguments. 5 and 7, there are two arguments. So when I will run, it will give me a type error. And that type error, it will tell me that math.sqrt takes exactly one argument, and I've given it two arguments. The same case when I want to compute the square root of 10 and 20. 10 and 20 are two different numbers, so it will give me a type error. So what you need to note, the square root function only takes one argument. Now, when I want just to compute square root of 10, when I run, you see it will run and it will give me 3.16, same to the square root of 20. It will give me 4.47. This means square root function only takes one argument. When you try to give it two arguments, it will give you an error. These other examples are just further example where I told you that Square root function is only applicable to either float or int numbers or integers. When you try to give it a string, it will throw an error and it will ask you that it needs a real number. Up to that juncture, I think you have understood about the square root function. That is the first function that we have covered under the math library. That is the first function that we have covered under the math library. The second function that we are going to cover is known as random, and this will be under the random library. The second function we are going to cover is known as the random. Now, what you need to know about the random function, it doesn't accept any parameter. It doesn't accept any parameter, and it normally generates a pseudo-random floating point number. It normally generates a pseudo-random floating point number. Now, what does it mean by a pseudo-random floating point number? So it just generates a number randomly in between 0 to 1. And those numbers are floating point numbers. What do I mean by saying floating point numbers? This means they have got decimal point. Now, when you are using this random function, I've told you they don't accept any parameters. When you try to put a parameter inside a random function, it will throw an error. It will throw an error. The second thing which you need to note, the first thing which you need to note about a random function, it doesn't accept any parameter. The second thing, it generates a pseudo-random floating point numbers in between 0 to 1. It generates a pseudo-random floating point number in between 0 to 1. Now, when you want to run this random number, you have to import it first from the random library. So you will say from random, import random. So this from random, this is the library. Import random, that is the function. So we'll get this random function from random library. And as I've told you earlier, it doesn't accept any parameter. So you'll just write random, then you'll open and close the brackets and then run. You see, when you run it, it gives you a pseudo-random floating point number, and this pseudo-random floating point number is in between 0 to 1. And you have seen it has given me at first 0.1375, and that number is in between 0 to 1. When I run it again, it will give me another random number, which is 0.2, and it has satisfied all the condition. The first condition, it is a floating point number. The second condition, it is in between 0 to 1. When I run it again, you see it gives me 0.4. When I run it again, 0.6, again 0.8, again 0.1, yeah, 0.08. So it will keep on giving you different numbers, random numbers, but those numbers, they will be floating point numbers, and they will be in a range in between 0 to 1. The second thing, I've told you that this random function, it doesn't accept any parameter. When you will try to give it any parameter, it will throw an error. And you can see here, I've said from random, import random. And in this random, now I've put 4 inside the bracket. And when I try to run it, it throws an error. Why is it throwing an error? Because random function doesn't accept any parameter. The random function doesn't accept any parameter. Another function that we are going to look at is the print function. The print function in Python programming is just for displaying. It's just for displaying. Therefore, it doesn't what can I say? It doesn't have any computational value. So for example, here, I want to test our print function for you to see how it doesn't have any computational value. For example, when I will say print, in bracket, then print 4, it will just print 4 as per the first instruction and tells me none. Why is it telling me none? Because print function is only for displaying and it doesn't have any computational function. Further example, which you need to know, uh, they are standard mathematical function. We have already done the square root, and in Python it is written as sqrt. Then we have the exponent. In Python it is written as exp. Then we have the log, and exponent, it computes e raised to a power. Then we have the log, which computes the natural logarithm of a number. Then we have log to base 10, which computes the common logarithm of a number. Then we have cos, and I think I've shown you cos up there. Then we have power. It just raises one number to a power of another. Then we have degrees. It converts values in radians to degrees. Then we have radians. It converts a value in degrees to radians. Then you have fabs. It computes the absolute value of a number. For example, yeah, when you want to get, for example, the absolute of 4, we'll start by saying from math, import star. And I've told you that when you import this star, it comes with each and every function within the math library. So when I want to get the absolute of 4, I'll just say fabs 4 and it will give me. When I want to get the exponent of 10, I'll just write exp, then in bracket 10, and it will give me the exponent. And you will just do the same. For example, if you want to get the power, I remember in our first lesson, I taught you, for example, you want to raise 2 to power 4. You just say 4, then in bracket, you say you want to take 2 raised to power 4. You just write 2, 4, 2, comma 4. And when you run, it will raise 2 to power 4. So those are just some of standard mathematical functions which are under the math library. So that question, I will not pass through it. That is complex for this certification. Yeah, this example, it just gives us a yeah, this is also complex for this certification. Let me go to time function. Now we have covered we have covered the math library. We have covered the random library. So we are going now to cover now the time functions. And under the time function, not time function, that was a typo error. It is time library. Under the time library, we are going to get two functions. The first function that we are going to get is the process time function, and the second function that we are going to get, it is the sleep function. We'll start with the process time function. The process time functions allows us to measure the time of parts of a program execution. The process time returns a floating point value representing elapsed time in seconds. So the process time, it just measures how long or how much time a program has taken to be executed. And it normally gives us a floating point value. And that floating point value, it is now the measure of that time in seconds. For example, we want to, I want to make a very small program, and from this small program, I'm going to use the process time function to measure how long the program will take to execute a certain task. So what am I going to do? I'll say now from time, import process time. Then I want it, for example, now to make a program which will be able to process the time when the programmer enters his or her name. So I'll say print enter your name. Then start time. So for you to get the time that the program has taken to execute, you must have a start time and an elapsed time. So you say start time is equals to process time. Then you say name input is equals to input. This function enables a programmer to enter his or her name. Then for you to get the elapsed time, this elapsed time is the time now the program has taken to execute or to generate a certain name. Uh, Now elapsed time is equals to now process time minus start time. And after it has computed, you have to allow your program now to display. For example, when I run and I give this program a name such as Ruth, and I press enter, you see it has, the program tells me the name was Ruth, and it took you 0.015625 seconds to respond. So the process time, it just measures the time that a program takes to be executed. For example, if I run it again and I enter a name such as Yvonne and I press enter, so it tells me the name was Yvonne and it took you 0.0625 seconds to respond. So when you want to measure uh, a time a program has taken to be executed, we normally use a process time function under the time library. The second the second example, for example, you want to do the sum of certain numbers. You want to do the sum of certain numbers, and after you have done the sum of these numbers, uh, you want to measure the time which the program has taken to execute the summation of all those numbers within a certain range. The first thing you have to set or to initialize, and the initial point is normally 0. So you'll say sum is equals to 0, then start is equals to process time. So why are we saying start is equals to process time? Because for you to process time, there must be uh, a start time and an end time. So this end time, we normally take it as a process time. We normally take it now as a function. So it says start is equals to process time. Now we want to get the summation of some numbers in the range between 1 to 100. So it means we are going to sum from our last lesson in iteration. I told you when you have been given a range 1 to 100, it means Python is going to compute from 1 to 99. So you'll say for n in range 1 to 100. So it will sum numbers from 1 to 99. Then you are telling your program to sum is equals to n. So that means now you are allowing the program to do now the summation. Then now it calculates the time. It calculates the time it has taken now to do that operation. It calculates the time it has taken to do that operation. So it will do that by saying elapsed is equals to process time minus start. So when you will run this, it will tell you that the sum is 4950 and it has only taken 0.0 to do that calculation. What if now we increase? When we increase, for example, two zeros, for it to do the sum from 1 to 10,000 and you run, it will tell you the sum is that number and the time is 0.0. So what I want you to get right, under the time library, the first function is process time. It just computes the duration of time a program has taken to execute. It just compute a duration of time a program has taken to execute. For example, when I use the same uh, uh, process time function, when I use the same process time function to in this program, you see it is telling me that Uh, the count is 15,6,443 and the elapsed time is 2.79 seconds. So basically what I want you to get it clearly, because what will be tested in certification is if you know how process time function is applied. Process time function is used under the time library to compute the amount of time a program has taken to be executed. These are just further examples of the same. Just further example of the same. We'll just pass through it. The second thing which I want to teach under time library is sleep function. Now, sleep function suspends the program execution for a specified number of seconds. It suspends for a specified number of seconds. I know each and every one of you, you have seen the traffic lights. It normally blinks and it waits for a specified number of seconds or minutes. So that is an application of a sleep function under time library in Python programming. For example, you want to count from 10 downwards up to 0, but you want your program to be sleeping. For example, when it has counted 10, it delays for a second, then it counts 9, then again delays for a second, counts 8, that way up to when it will reach 0. So that is why we use the sleep function. So you will start by saying from time import sleep. Then now you will make a loop or an iterative. So you'll say for count in range. For count in range, you want to count from 10. So you'll say 10. You start by saying now this 10. Then to -1. This means it will count from 10 up to 0. It will count from 10 up to 0. When you want to count from 10 up to 0, you will put here -1. When you want to count from 10 up to 1, you will put here 0. So you'll say 10, then -1. It means you are counting from 10 to 0. Then you want the sequence of that count uh, to have a difference, of to have a difference of 1. So when it will count from 10, it will go to 9, then 8. That is what it means by this third -1. Then you will want your program to print now the count so that it can display from 10, 9, 8, 7, that way. Then now you will use the sleep function. Now, after it has printed 10, how long do you want your program to wait before it prints 9? Then after it has printed 9, how long do you want it to wait before it prints 8, 7, 6, up to 1 in that order? So for example here, I put 5. That means the program, after it has printed 10, it will wait for 5 seconds before it prints 9. Then it will wait for another 5 seconds before it prints 7, in that order up to when it will reach 0. So when I run this program, you will see that it will be waiting. Let me run. You see it has printed 10, then it waits. Then 9, it waits. 8, it waits for another 5 seconds. Just be observant until it reaches 0. Now I think you can see it has printed from 10 up to 0. And after it printed 10, it waited for 5 seconds before it printed 9. And it it was following the same order until it reached 0. Now, what I see when I change here, for example, and I put it a number like 2, it means it will be waiting for 2 seconds before it prints the preceding value. For example, when I run, it will print 10, then wait for 2 seconds, print 9, wait for 2 seconds, that way. So that is just an example of how a sleep function within the time library is used in Python programming. So we have covered the math library, we have covered the random library, we have covered now the time library. In the math library, I've shown you different functions such as square root, cos, sine. Coming to random library, I've shown you how to generate random numbers using the random function. Then under time library, we have covered 2 functions, that is sleep and process time. So we are going to other some more examples inside the random library. So we want to generate the random functions. We want to generate the random function, and as I have illustrated above, you have seen uh, how I've used the random function. And from this definition, it says that it returns a pseudo-random floating point number in the range in between 0 to 1. And that one I told you, and you saw it returned a floating point number, and that floating point number was in the range in between 0 to 1. The second thing about the random function, it doesn't require any parameter. That is the second thing. It doesn't require any parameter. So we have covered the first one. We are going to cover the second one, the rand range. So in this rand range, it is the opposite of now the random. In the rand range, it requires a parameter, and that parameter it requires 2 parameters. It requires 2 parameters because rand range, it means you are going to specify. You are going now to specify what you are going to specify the range. Then when you are when you are computing this rand range, you can decide to have a seed. What is now the purpose of a seed? It says the random number seed. What is this random number seeds? It determines the sequence of the generation of these random numbers. It determines the sequence of the generation of these random numbers. And in the example, I will show you, and also the other importance of a seed. It makes now when you are running a program, and this will be very important when you will be tackling Python for data science. You normally it is advisable for you to have a seed. Why? Why is it advisable for you to have a seed? For example, when you are running a machine learning model such as a decision tree classifier or linear regression, you must set a seed. What is the importance of this seed? The seed will enable the programmer to get the similar results each and every time you will be running that program. And for sure, you are going to see it here. When we have a seed, you will be getting the same results of the random numbers. But when you exclude the seed, you will be getting different results of these random numbers. For example, now, in this example, I'll say from random, import rand range, and also I've imported seed. So I've set my seed to be 5. Then I want to get the random numbers, 100 random numbers. I want to get 100 random numbers. Let me repeat. I want to get 100 random numbers in a range between 1 to 1000. How am I going to write that program? So I'll say for I in range 0 to 100. So this first line of code, it means I want to get 100 random numbers because it will count from 0 to 99. So those are 100 random numbers. Then the second code, I say print rand range. Now this rand range, it is 1 to 1000. That means these random numbers, these 100 random numbers should be in a range between 1 to 1000. Should be in a range between 1 to 1000. Then I will have this last print. This last print, it signifies that I want everything within the body to be displayed. Everything within the body to be displayed. So I have set my seed to be 5. I have set my seed to be 5. When I run this program, you see, I want you to be very keen. Look at my first value. My first value is 638. Just look at the first value, 638. When I run this even 10 times, see, I'm just running. The first value will just remain constant. The first value will just remain constant. It will remain 638. So that means all the values here, it will remain constant. But I'm just using 638 as a dummy. But it represents that each and every number here, it will just remain constant. Why? Because as I've told you earlier, when you set a seed, it ensures that you get similar results whatsoever the number of time you will run that program. And also, the second thing you need to note, uh, different seeds will give you different values of random numbers. Different seeds will give you different values of random numbers. For example, yeah, if you see the first value is 638 when I have a seed of 5. But when I change this seed and I put, for example, 10, I put 10, you will see the values of random numbers of these 100 random numbers will change, but it will be in a range of in between 1 to 1000. Just see, you saw when it was 5, the first value was 638. But now let us observe when it will be 10. When it will be 10 and I try to run, you will see now the first value has changed to 586. But it will just, so long as I will have the seed of 10, it will just remain to be that 586 whatsoever the number of times I will keep on running this program. So, and also when I change the seed maybe to 30, you will also realize that uh, also these random numbers, these values of random numbers, which are 100 in number, you saw when it was 10, the first value was 586. So when it is 30 and I run, you see now the first value has changed to 553, and it will remain that constant whatsoever the number of times I will run. Now, I want you to get the difference. When now I will remove this seed, when now I will remove this seed completely, and by removing it, I just comment it by putting an hash. That means I've removed it. Each and every time you saw when I add the seed, each and every time I was getting the constant value. But when you remove the seed, it will cause the when I remove the seed, you will see that when I will try to run this program, each and every time I will be getting different values. For example, let me run it for the first time without a seed. You see it has given me the first value here is 106. When I run it again, it gives me the first value there is 541. That is a specimen which shows that each and every value has changed. When I run it again, it gives me 514. I run it again, it gives me 889. I run it again, it keeps on changing. So the importance of a seed, it will ensure that you get a constant value of those random numbers. So that is what I want you to get it clearly. Now, the last thing in this topic is about importing issues. And I think that is the first thing which I started with, importing issue. I told you there are 3 ways of importing. The first way is where now you specify the functions which you want to import. And I told you, you can say from math, import sqrt. For example, if you want to import the square root, or you can say from math, import log. That is the first way. The second way is if you want now to import everything within the math library, you'll just say from math, import star. It will come up with each and every function within the math library. The third way is where you just say import math. Import math. But for example, when you want to do the square root, you will say now math.sqrt. Or when you want to do the cosine, you'll say math.cos. So those are three different ways of importing. Those are three different ways of importing in the math library. So that is the end of our lesson today, and it signifies the end of chapter 6. Any question? Any question? If any?
Hello.
Yes.
I'm sorry. When you say chapter 6, is that chapter 6 in the book?
Yeah, that is chapter 6 in the book.
Okay.
Yes.
And you said that we have only one library, that is the math library.
Yeah, we have covered the three library in this lesson. The first library which we have covered is the math library, and under the math library we have covered a number of functions. The first function under the math library we have covered it is the square root function. The second library it is the cos. The third library was the sine.
So
and I
those
gave you
functions
some
are
other
equally
examples.
libraries.
No, there is a different. The functions comes from libraries. So, for example, square root, absolute, cosine, sine.
Those are functions from math library, right?
Yeah, those are functions from math library.
Okay, which is the other library that you talked about, apart from math library?
The second library which we have covered today is the random library.
Oh, random. Yeah, okay.
And under the random library, we have gotten three functions. The first function was the random function. The second function was the rand range function. And the third function was the seed function.
And then the other library?
Then the last library which we have covered today is the time library.
Oh, yeah. Got it.
Under the time library, we have covered two functions. The first function was process time function, and the second function was sleep function.
Okay.
Yes.
That was so.
So in chapter 7, I think, which although today I've finished very early, but I can't introduce chapter 7. In chapter 7 now, we will cover more on functions where you can be able to define your own function. For example, you want to make your own function Ruth, and you call it Ruth. So in chapter 7, you can be able now to make your own function. So that is where now we will cover definition of functions.
So is it question time, Mr. Bushuru?
Yeah, it is question time.
I also have a question. Am I allowed to ask?
Yeah, you can ask.
Yeah, stop sharing, please. Stop sharing your screen so that I can see everybody. Yeah, thank you, everyone. So you want to put on your video? Yes, Amos, how are you doing? You are on mute, please. You're on mute. Where is David? Yvonne, where is David? Yvonne, are you there? Maybe Yvonne is not there. Was David in class today?
Yeah, he was there. He was there.
Yvonne, can you hear me? Yeah. Bushuru, can you text him? Do you have his number? Can you text him to come back? Just for a few minutes.
Okay.
So, yeah, text him to come back. Yeah, Amos, you have gone again.
You
Put
want
on
me
the
back?
film.
Okay.
Yeah, coming back. Okay. And I
Alright.
hope you're hearing. Yeah, so it looks like everyone has already done his or her part of the bargain. The little fee collection here in this class is 100%. Congratulations. This means we are serious about what we are doing. Now, as per the contract, what remains is now us
Uko bado kwa mute.
to,
Okay. So
us now to do our part of the bargain.